This is lesson 3, chapter 8, area of composite figures. And the first two lessons of this chapter, we discussed circumferences and areas of circles. Okay, we go back to the essential question here. How do measurements help you describe real-world objects? Again, when we talk about composite figures simply mean that's a combination of different figures into one. Okay, let's see what that means later on. But right now, uh, it's asking for list two real world scenarios in which you could use the area of a composite figure. So one good example is when you want to calculate the amount of fabric when sewing a jacket from a pattern. Because when you sew a jacket from a pattern, you are combining different shapes, different figures to find the area. And also when you want to calculate the amount of floor space when carpeting a room is not necessarily just rectangular or square. Sometimes it is comprised or it is composed of rectangles and a group of rectangles or squares, or sometimes even semicircles. Okay? So those are scenarios where we can use this particular concept that we are discussing here. Okay? So for this particular lesson, we want to find the area of a composite figure. And let's go right away to the concept here. When you talk about a composite figure, definition of a composite figure is made up of two or more shapes. Okay, and when we want to find the area of a composite figure, we decompose the figure into shapes with the areas that we already know. Okay? Then you'll find the sum of these areas, and that's how we find the area of a composite figure. Okay, so first we decompose the area into the shapes we know, and then we find the sum of these areas. Okay, so let's take a look at a parallelogram. Remember what a parallelogram is. Parallelogram is a quadrilateral, okay, with at least two pairs of parallel sides. And when we want to find the area of a parallelogram, okay, the parallelogram is a product of any base and its height. So the formula for finding the area of a parallelogram is simply base times height. Okay, good example of a parallelogram is something like this. That is a parallelogram because it has two parallel sides, and we want to find the area of our parallelogram. We simply get this is our base and this is our height. So we multiply base times the height of a parallelogram and we find the area. Okay, the next shape that we're going to talk about is a triangle. And again, the area of a triangle is half the product of any base and its height, h. Or the formula for area of a triangle is 1/2 base times height. So again, if I'm going to draw a triangle, okay, this one right here is a triangle, okay, this is our base, and again, this is our height, okay, this little square indicates it's a right angle, okay, that's our height, and the formula for finding that is 1/2 base times height. The next shape we're going to be talking about is a trapezoid. Trapezoid looks something like this. Okay, that is a trapezoid. Okay, when you have one pair of parallel sides. So to find the area of our trapezoid, it is half the product of the height and the sum of the bases, base 1 and base 2. So if this is our trapezoid, this is our base 1, this is our base 2, and this is the height of our trapezoid. And the formula is given as area equals 1/2 times the height times the quantity, okay, base 1 plus base 2, or B1 plus B2, okay? And finally, this is the formula of an area we just talked about in the last lesson, which is the area of a circle. And the area of a circle is nothing more than equal to the pi times the square of the radius, or area equals pi r squared. So that's the last shape that we're going to talk about for this lesson. Okay, so that's our circle, and this is our radius. Okay, so those are the different shapes that we know of. Okay, and some composite figures that we can look at. Some examples are this particular composite figure. You have a parallelogram here, and you have a rectangle. So this is a combination of two shapes. Another example of a composite figure is given here, where you have a square and a semicircle, or half a circle. That's another composite figure. And this is another one right here, where you have a trapezoid here, and you have a triangle right here. So basically, if we're looking to find the area of this composite figure, we are going to use two formulas: the area of a parallelogram and the area of a rectangle, which is basically the same as the area of our parallelogram, because a rectangle is a parallelogram. To find the area of this composite figure, we need to find the area of our square, and then we need to find the area of this semicircle. To find the area of this composite figure, we need to find the area of this trapezoid, then add the area of this triangle. Okay? So let's see how this works in our examples. Find the area of our composite figure here. So you have a triangle here, and you have a semicircle. Okay? So let's first find the area of our semicircle right here. And if you notice, it has a diameter of 6 meters. And if it has a diameter of 6 meters, our radius will be equal to 3. Remember that radius is equal to diameter divided by 2. Okay, so again, we write down the formula for area of a semicircle, which is 1/2 times pi r squared. We substitute the value for pi, which is 3.14. The radius will be equal to 3, okay, as mentioned. So the approximate area of this semicircle is 1/2 times 3.14 times 3 squared. Okay, we simplify that further. This becomes 9. 1/2 times 3.14 times 9 is actually equal to around 14.1, about 14.1. Okay, so that is the area of our semicircle. Let's find out the area of our triangle. So our area of a triangle, this is our height, and this is our base. And we know that the formula for area of a triangle is 1/2 base times height, according to our table right here. 1/2 base times height, and we simply substitute the base and the height. The base being 11 meters, and the height being 6 meters. So you multiply 11 times 6, which is 66, times 1/2, should give you 33. Okay, so the area of this triangle is equal to 33 square meters. So the next thing we need to do is simply add those two areas. 14.1 plus 33 will give us 47.1 square meters. So that's the area of our composite figure. Okay? All right, do the got it problem, and let's see if you understand example number 1. Let's take a look at example number 2. You have a miniature golf hole. It's composed of a trapezoid and a parallelogram. Okay, so this is your trapezoid, and this is your parallelogram. Okay, how many square feet of turf does the hole cover? So let's first find the area of our trapezoid. This is our trapezoid right here. This is base 1. Okay, actually, that's not base 1. I'm sorry. This is base 1. This is base 1. Let me put that again, base 1 and base 2, because these are the two parallel sides. These two sides are parallel, so those are our bases. Okay? So if those are our bases, base 1 and base 2, let's find our formula. 1/2 times the height, base 1 plus base 2. And since 3 will be our height. Okay, so substitute the values. When we substitute the values, we know 1/2 times 3, which is our height. Okay, this is base 1, 2, and this is base 2, which is 3. So add those two first. 2 times 3 is 5. 2 plus 3 is 5. Times 3 is 15. 1/2 of 15 is around 7.5. Is equal to 7.5. So let's take a look at the area of our parallelogram. So this is our parallelogram. We have two pairs of parallel sides, and this is the height of our parallelogram. Remember, the height is always perpendicular to the base, or it forms a right angle with the base. So the height is 2.5 feet, okay? And the base is 6 feet, okay? Now you notice it's giving you 3 feet here. This does not matter. You're only looking for the base and the height to find the area of this parallelogram. So again, let's find the area of this parallelogram by using the formula base times height. So we are going to use only 2.5 and 6 feet. Once we do that, okay, we now have, okay, 6.5 times 2.5 will end up with the value of 15. So we simply add 7.5 plus 15, okay, will give us 22 square feet. That's the amount of turf that will be needed for this particular composite figure. Okay? All right. Pedro's father is building a shed. Do the got it problem, and let's see if you can solve Pedro's problem. Okay, let's find the area of the shaded region here in example number 3. So the shaded region is this one right here. Okay, and if you notice, okay, this is a rectangle and this is your shaded region. Okay, so let's see how to find that particular area of this composite figure. Give me 1 minute here. My thing is freezing. Hold on, it's still frozen. Give me a few seconds. There we go. I think I figured it out. Yes, I did. So find the area of our shaded region. Let's go back here. So for us to be able to do that, you need to first find the area of the rectangle and subtract the area of the 4 triangles. Remember, this is our rectangle, and you have 4 small triangles there. And in our triangle, the base is, we can either make this the base or the height. They're the same, it doesn't really matter. So in our triangle, the base is 1, the height is 1, or vice versa. Okay? And in our rectangle, we know that the base is 12 inches or the length is 12 inches. The width is 5 inches. We can also make this the base and make it the height, or that's interchangeable as our length. This is also our width, because in a rectangle, area is also length times width or base times height. Okay? Okay, let's first find the area of a rectangle. And in a rectangle, we know it's a parallelogram. And the area of a rectangle is length times width, like what I mentioned. So we simply multiply the length, which is 12, and the width, which is 5. So 12 times 5. So the area of this rectangle is 60 square inches. Let's find the area of our triangles. And first, we need to know the formula for area of a triangle. The area of a triangle is 1/2 base times height, but there are 4 of them. So we multiply it by 4. Okay? We know that the base and height of our triangle is 1. So 1 times 1 times 1/2 times 4. And that should give us a value of 2. So the area of our 4 triangles is 2 square inches. So we simply now look at our triangles right here. They are not part of the shaded region. So what we are going to do is we're going to get the area of our rectangle, and we are going to subtract these 4 triangles with an area of 2 square inches. So that's exactly what we're going to do. 60 minus 2 will give us 58 square inches. Okay? And, oh, there's no guided problem after number 3, so we'll go on with guided practice. No, sorry, example number 4. So in example number 4, you are given this blueprint. So in this blueprint, for a hotel swimming area, it is represented by the figure shown here. This is the figure. This is the shape. The shaded area represents the pool. So this is the swimming pool of the hotel. Okay, we want to find the area of the pool. So let's analyze this. Okay, guys. So we have different composite figures here. We can get the area of the entire rectangle. Okay, and then we can subtract the area of this square, well, of this rectangle from the area of our entire rectangle. Then we get our shaded region. So basically, we get the area of a rectangle, that's our plan, subtract the area of the non-shaded region, non-shaded, okay, that will give us the area of our shaded region. Okay, so we're getting our plan is to get the area of our rectangle, this whole thing, and we are going to subtract the area of our non-shaded region. That'll give us the area of our shaded region. Okay, so that's exactly what it's saying here. Find the area of the entire rectangle and subtract the section that is not shaded. So let's look at the area of a rectangle. And we know that the area of a rectangle is a formula of length times width, the length being 42 and the width being 25. So this is the length of a rectangle and this is the width of a rectangle. So we substitute those values. We have 42 times 25 will give us 1050. Okay? So that's the area of a rectangle. Let's find the area of the non-shaded region. Area of the non-shaded region will have a length that is 22, and it will have a width, which is this one right here, which is also equal to 20 meters. So again, we go back to the formula of area of a rectangle, length times width, the length being 22 and the width being 20 meters or 440 square meters. So basically, again, we are subtracting. We are getting the area of 1050 and we are subtracting 440. And that's exactly what's happening here. So the area of the pool of the hotel is 610 square meters. Okay? All right, let's do the last guided problem and let's see if you understand examples 3 and 4. And that's the end of our lesson. Thank you for watching.